Good afternoon, guys. This is Krishnakant Khundia, and today we will see a presentation about this webinar is all about HTTP request smuggling, and today we'll see how in a live environment it works, and as a pen tester, what we will see to find this works. Alrighty. So let's start the presentation, and today PPT will be followed by what is the basic introduction to HTTP request smuggling. Then we will follow by how HTTP 1 and HTTP 2 is working and what is the flaws in 1.1 as compared to 2.0. And we'll see how CRLF uh, create a important role in HTTP request smuggling. And we'll followed by a demo in live environment. So for the first, what is HTTP request smuggling? So this is basically a desynchronization attack where the front end and the back end accepts different ending line that's make a desync and format a request smuggling. And when we request when a request get queued due to desync, then we can see caches, tokens, cookies in the server. Then what is HTTP 1.1 and why it is prone to request smuggling? So in HTTP 1.1, this uses two type of encodings. One is your content length and another one is transfer encoding. The content length, and if there is a mismatch between those, we can smuggle a request to another. So basically 1.1 also uses a CRLF, that is our carriage line and line feed. In the next slides, I will make you understand what is CRLF and how it works. But in simple, CRLF makes those servers think that where the body ends. Next is HTTP 2, and this is the safer from 1.1 because it uses a tunneling. So two requests, we can smuggle two requests. We can pass two requests in the two servers, but a servers accept one request. That is, we can call it binary framing. And what is binary framing? We can say that every body has its own length, so that is fixed, and that makes it safe from HTTP 1.1. So we're followed by the first encoding method, that is content length. So when you pass the data into the body, so the content length max reads every n bytes of the data, and it is updated. It is auto updated. As we can see in the example, there is a post request. So the important is why we are using a post request in a HTTP request smuggling, because a post request contain the content type and the content length. So every time we smuggle a request, we will use post request. So you can see that the content length is updated to 10. That is our hello world. So the hello world contains 10 bytes of data. So it is updated to 10 bytes. So another formatting is we can call transfer encoding. So what we can see that this is same the post request we are passing hello world, but this time we are passing first the chunk value, and it is a hex code value. So first 5 is passed, then the server reads hello, then another server again reads that there is 5 hex code and 5 bytes of data and reads world, and after that when the server gets 0, when it sees 0 it stops, and that's how transfer encoding works. So these are two different formats that we use in it to read the data. We can say the to end of the data. We can say. So what is CRLF and why it is important in HTTP request smuggling? So the CRLF is the carriage return and line feed. These are two ASCII value that is followed by /r and /n. So so by this the servers knows that where to end, where the body ends, and it is used in two content length and your transfer encodings. S- So every time there is a /r and /n, the service knows that there is a completion of body, and we have to stop reading the next values. It may be the content length for the data, or it may be chunk values. So this is a lab environment, and today we'll see how we can know that how can detect is there is a actual a bug that the web server is desync, and we can able to send a smuggle request to the server. So to detect, so first you can see that this is in HTTP2. I have taken two requests. One is for smuggle, we can make it for smuggle, and another is a normal request. When we pass it, we get a 200. Okay, then we have a feature in Buffsuit that we can check change into HTTP1 attribute header, and we can see that it's actually working or not. So it is working fine. So this is a as this is a GET request. I already said that we have to take a post request so that we get our content body and content length. Okay, fine. We get that, and I'm just removing those extra headers that are not required. Okay, this is working fine. So when I'm writing hello world and I am passing into the server, the content length is updated to 14, and we can see here I have sent the slash r slash n. This is your CRLF. Yes, this is updated to 10, and the hello world we can see that this is 10 byte of data. So this is all about content length. When we add another encoding method for transfer encoding, and it is passed chunk. So this delay, by this delay, we can detect that, okay, we get a error about 500 internal server error. And why we get that? Because when we pass transfer encoding chunk, the server doesn't able to read those chunk values. We already seen that we for chunk, we have to first pass a chunk value, then the below data. That's why we get a communication timeout. So let's correct this one. For hello world, we'll take the chunk value as 10. This is the chunk value, and it is will be closed by 2 followed CRLF, that is slash r slash n. We have to correct this. So we can see that we get a 200. Okay, then so this is what we when we given a chunk value for hello, it is 5 bytes, and for volt it is also a 5 bytes, and it is followed by 0. The front end server takes a content length for So that is why it is updated to 25. We can also see that in this. This is the chunk value that is updated to 25 bytes. Okay. So what will happen here? We can see. So make it more simple. So what is happening here? So when we given a transfer encoding chunk, the front end server, what it counts bytes, that is 18 bytes from 5 to 4. This is 0. So this is here is 18 bytes. There I happened in request, we also mentioned that for G. So when I added a G here, okay, this is fast. So what is happening here? The front end accepting 18 bytes of data, but when we also see that the backend server transfer encoding, that is chunk value, and after seeing chunk value, so the server stops when seeing the zero, the chunk values ends with the formatting with zero, and after that our G and what we have smuggled the request about any request we smuggled, it will pass for the next it will pass for the next queue for the server, and our next request will be smuggled. That is also written here. Our front end and back end here is desynced, and when the front end is accepting the content length, but the back end is accepting the transfer encoding. So the backend just rejects those content length and it will update to zero, and the next request will be passed to for we have smuggled the request. So you can also see that here I have the G. So for the normal request, when I'm sending this, the request should be 200. Okay, but okay. So I'm sending this. So I have gotten an on-recognized method that is zget. So what is happening here is this method. This method is attaching here. This is how the next request looks like, and this is how we can smuggle a request for the into the server for next. So basically the G goes into the buffer for the next request, and this is attached for the next request. So after this we can also retrieve those accounts or see those cases in the servers. So this is a demonstration where we can understand that how a basic CLTE formatting works, where the front end is accepting content length and the back end is accepting transfer encoding. So in the next lab, we will see how the front end, if the scenario changes and the front end server is taking transfer encoding and the back end server is content length. I will make you explain how you can detect those one, and we can see how we can smuggle those requests into the server and make it desync. So this is another lab that contains a basic TECL where the front end is accepting a content length. Sorry, the front end is accepting here is transfer encoding and the back end is accepting content length here. So we'll make it see that how we can detect this one. Okay, it is working fine. Then we'll change the attributes for HTTP1 and we'll change the request to a post request. So we'll add the encoding that is our transfer encoding. So when I'm passing a hello, the normal text, so it takes the time and the server detects that. We will detect a 400 error and 400 response means we will get a browser error. So we can understand that we have an error in our front end. Okay, as we can see that there is a 400 error. So we know that there is something error and a desync here. We get a desync error that our browser is not able to understood that it is not taking the content length as a 5, it is taking a transfer encoding chunk. So when we'll update the value to chunk, it will work fine. Okay, it is working fine. So we know that this is our chunk value and the front end is accepting here is the chunk. And what we'll do is we'll make the thing the server is asserting your content length and we will parse a next request, our smuggled request into this, will embed into this so that this will goes into the server and we'll finally able to smuggle those requests. So what we'll do is if here we can see that this is about 3 bytes and what we'll do is we'll make the content length update. We'll stop this to update, auto update the content and we'll make it to 3. Let's say I will do 3. So what will happen here is the front end will accept the transfer encoding. So it will take hello and it will stop your 0. But when it will goes to backend, the backend will just reset those transfer encoding. It will accept content length 3. When it will see content length 3, so this will be taken by the read by the backend, but this request will be passed and this will be in goes into buffer and it will be smuggled to the server. So let's see how we can do this. Okay, we have to get an error that is 403 byte and that is on recognize method hello zero get. So this is how the transfer encoding TECL basic TECL work. So we can see here that that also what is happening here. The front end is asserting a chunk value, sees a value for let's say here of 1, that is our G value, and after seeing 0, its end, the body ends here, and here the front ends is working fine. But when it comes to backend, the backend will see there is a content and it will reset those transfer encoding chunk values, and it will see the content length 3, and after seeing 3, this will that is our CRLF. Then what will happen is after seeing the content length 3 RN, this Z0 will be goes to buffer and it will be passed to the backend for a smuggled request. This is how basic TCL works. And this is not limited to here. We can also pass we can pass actual request to the server so that we can get the admin access and we can do so many things with request smugglings like privilege escalation. We can get cookies, we can get caches, we can get session tokens, we can see those headers containing host IPs. A lot of things we can do by smuggling this request. So the final, as a pen tester, I will conclude that how a pen tester will be find those requests so that I can know that there is a in the application there is a bug for HTTP requesting. The first checklist is check for desync. So check those error pass content length, pass transfer encoding to the front end, and check there is you will get a error that is one is your 400 error, one is 500. If you get a 400 error, that means there is a browser side error. According to it, you will pass. Yes, according to the environment, you will pass a TECL or CLT. The same goes applies to the 500 request server. So 500 means there is a backend error that is our. So you can able to know that what is actual the front end is taking or what is actual the encoding backend is using. So these are the basics how you can know. Again, we can see that if one is using application using a header HTTP 1.1, so we can check those. And there are automations we can apply. This is one is manual. There is also automations are there for HTTP request smuggling. You can just add those URLs and you can able to see how the backend is passing. So you will get a error for desync, and according to it, you will apply to smuggle those requests. So thank you for today's webinar to joining us. So if anyone have any queries, you can ask. I will able to. Hello. Mm. We have a question from Biswajit Nayak. Is it possible to do with HTTP2? Yes, Biswajit, we can do with HTTP2, but if the developer has not configured it is for tunneling, we can absolutely those we can do. So when a developer not configured with tunneling, what we can do that the actual request may be degraded to 1.1. So the developer need to fix those that only HTTP2 will working for those applications. We can't downgrade to 1.1. If we can downgrade to 1.1, if pipeline is not working, then absolutely in HTTP2 we can do those request make it smuggle to the server. On current coaching. We get another question for Arnav. He asks us what can be the impacts of the attack. Arnav, we can do many a lot of things with request smuggling. We can smuggle our request for admin access. We can request smuggling for get those caches if there is any URS touch pass any search value. We can smuggle a request with a buffer value, and where we can get those internal IP status headers that contains those hosts. And if attacker those internal headers, he can access into the servers, right? We can also do accesses here. Accesses we can also pass in through open redirect. We can also pass uh, X-frame headers into those to deface the applications. So these are the impacts, basic impacts that happens to the attack when attackers do HTTP request smuggling. Mm. Guys, we will wait for another 2 minutes. If we don't get any question, then we'll wind up. And after this webinar, you can ask those questions into our comment section, and we will able to clear those doubts. Yeah. So thank you guys for joining us, being a part of this session. For your next queries, I will able to pass your doubts in the comment section.